Hello guys, welcome and let's look at this question. And I read the question. Two semicircles are inscribed in the square. Find the area of the shaded part. Guys, we want to find the area of the shaded part. And the length of a square is sides 2. And so therefore guys, now we begin to do the question. So guys, I have already drawn this sketch right here, whereby I have completed both of the circles. And now guys, for this point, we have drawn the x and the y axis. This is x axis on this side and y axis on this side. And this is our origin. The first thing guys, we get the equation of those two circles. And that is going to help us to get the points of intersection. And after that, we can now be able to get, first of all, the area of this intersection. And then, guys, we shall continue. I will tell you what we shall do. So, guys, the first thing I have done is to establish the equation of those two circles. So, this is now the equation of a circle. That is a circle which has the origin, which is away from the origin of x and the y axis. And we use this equation to find the area of that, the equation of that circle. So guys, for A, this represents the distance away from the origin to the center of the circle. And therefore, for this circle, we shall have 1 at this, we shall have 0 at this point. And this is the distance, the y through along the y-axis to the center of this circle, which now, guys, this is 1. That is for this circle. And so for this other circle, we shall have 1 represented by A, because the distance along the x-axis from the origin to the center, or this other one will be 0. And that's what, guys, I have done right here. For the circle A, we have this equation. And for the circle B, we have this equation. Guys, now we need to get the point of intersection. And that one can be done by solving this simultaneous equation. And when we continue like that, guys, we shall have this simultaneous equation. And therefore, guys, as you can see, this is almost all the terms are the same except these two terms. And therefore, we can say negative 2y should then be equal to negative 2x for the equation to be satisfied. And therefore, we shall have minus 2, y equals to minus 2x, and therefore y is equals to x. And now replacing for x, guys, we can now be able to get, using the first equation right here. This is the equation we are using. We're replacing for y with x. And therefore, guys, we shall have this. We shall have x equals to 0. And at that time means that y is also equals to 0, because we have y is equals to x. And when x is equals to 1 for this, then y is also equal to 1. And therefore, guys, our points are 0, 0, which is here, and also 1, 1. So at this, we have 1, 1. Those are the points of intersection. Guys, for us to be able to get this area, we need the distance between the two centers. And the distance between the two centers can be given by, we have one here and we have one here. So this is the horizontal. And guys, using the Pythagoras theorem, this one comes to square root of 2. So this is the square root of 2, and it is easy to get that. And so therefore, guys, we can now come and find the area of this shaded part. And the area of that shaded part is actually given by this equation. This is the equation that gives us the area of the shaded part. So guys, we just come, because these circles are of the same radius, we just come and replace for R. For R, this is 1, and for D is square root of 2. So when we replace, guys, this is how it is going to be. And finally, this is now going to be the area of the intersection. And this is the area we are talking about. For us now to get this shaded area, guys, we are going to get the area first of all of the square, which is 2 times 2, 4, and then the area of those semicircles. And because of this area that is shaded, guys, we are going to take away from these two semicircles. And that can be done by just getting the area of one circle, which now can represent this semicircle and this semicircle. And this is how I have done it, guys. This is the area of the shaded region now is what we are looking for. We shall have the area of a square minus the semicircles, which is one circle, because these semicircles are 2. Now minus the area of intersection. And this is the equation, guys. Area of the two semicircles, pi r squared, now minus the area of intersection. Guys, when that is subtracted from 4, guys, we shall have this. 4 minus pi plus pi over 2 minus 1. And finally, guys, this is our solution. Guys, our solution is 3 minus pi over 2. And so, guys, this area is 3 minus pi over 2 units square. And thank you guys for listening to me. Bye bye.